Hi everybody, this is strategy 6, which I call Refute It, just because I have another thing called Link It, so I was trying to keep that same kind of pattern going. I find that students oftentimes will relate to real stories a little bit better, and so I often try to present real-world scenarios for the students in which they can try to tell me where the incorrect understanding of physics lies. So, there's a lot of misconceptions about physics out there. There's probably a lot of misconceptions about a lot of subjects. I find that physics has a lot of them, and so I need to try to attack those. And also in the process, I feel like I can use this as a way to assess where students are thinking, and also and this is what pertains to this in particular, use it to get them to write an argument that might support their position about which misconception is there and then why it is a misconception. I think it's easier to take a position against something than it is to take a position in favor of something when you're arguing. And so I think this particular process is actually a pretty good one. This original rubric and some of the ideas came from a Science Scope article back in 2008 called Learning to Write and Writing to Learn in Science. It's actually for middle school students, but I think it's got some good ideas, and I guess I took a lot of other ideas from a number of different areas, but that's really the main source that it comes from. Again, I use it for these two purposes: to identify misconceptions and to be able to support an argument with evidence. Particularly, I would do this after we did a lab on a particular topic and then presented them with the misconception to see if they could correctly identify it. The template itself looks like this. So I have some directions here, some very simple, easy directions. Believe it or not, this is not a spreadsheet. I know. I feel a little weird presenting it, but there it is. It's not a spreadsheet. And then what I do oftentimes is I go ahead and give the students a scenario. And so the question that I ask them is, in this scenario here, can you identify what the misconception is? And then they have to come up with an argument in favor of one particular topic being the misconception, and then give me the reasons and evidence that support their claim. And again, I would do this after the lesson. So this would be sort of a formative assessment at the end of the lesson or near the end of the lesson to be able to see if they've got understand what the misconception is and have attacked it in such a way that they no longer believe it. At least they tell me they no longer believe it. I don't know. You know how things go. Anyway, so here I have an example. So I put the scenario here under the argument part because I don't really want them to write anything about it. I just want them to identify it. And so I'm going to move the screen just a second here. There we go. So you can see what I'm doing. So I want to highlight the part of this paragraph that has the misconception in it. So I put up a funny, silly description of what could be an actual scenario, and then have the students try to look at it and try to identify where the misconception is. There's a lot of physics in here, so you can kind of see that I'm trying to hide the misconception in amongst good science, and so I'm trying to distract them a little bit with that. The way that I want them to do that, and it says this in the instructions here, is to use the highlighter tool for Google Documents. And so to do that, you highlight the text that you think is the misconception. And in this case, I will tell you the misconception is actually buried right there. When you turn a corner, nothing pushes you towards the outside of your turn. That's just inertia, right? So I'm going to go ahead and highlight that by going up and clicking this text color tool right here. Now, normally I stick with this text color, and I like to color my text different colors, but in this case I want to switch over to the highlight tab and then I can pick a color that I can use to highlight this. And I usually suggest that the students stay in this top row right here, because otherwise it gets pretty hard to read. But then they can choose whatever color they want in that top row. And so I always choose this light cornflower blue 3 right there. That's my go-to color. This is a dark cornflower right there, so you get the sense for it. Anyway, so now I have that highlighted. That's my argument. My argument is this is the misconception. Okay, so now I'm going to come back down and say, all right, so how can I support that? And we did a number of experiments which tried to convince students that there was no turn. There was nothing that pushed anything to the outside of a turn, even though you felt it that way. There was nothing actually there that was pushing you. And so I would expect them to list off here the reasons and then cite the experiments that we did that sort of counteracted this idea. I did put a rubric on there. I just grabbed this rubric right from the article that I mentioned above. So it's just something that I can use very quickly. Did they identify the misconception? Did they give me reasons? And did they support it with evidence? So it's very simple, very straightforward. Again, this is meant to be something fairly quick for the teacher. The longest part, of course, is to come up with this kind of a thing. So typically, if you can find a real-world description that you can use, that's actually a much better way of doing it. So you don't have to actually come through and come up with the scenario for yourself. I just wrote this very quickly. Quite honestly, it didn't take very long. It took me about, I don't know, 4 or 5 minutes, something like that, to type this up, because I had a pretty good idea in my head of what the misconceptions would be. To do this before you do it, you might want to list off misconceptions for each unit, and then think about how you attack those misconceptions, and then from there you can come up with your scenario for the argument part of this. So hopefully that makes sense. Really, that's it. That's really all there is to it. It's not, again, not earth-shaking, but the goal at this point is to have the students make a simple argument and then have to support it with reasons and evidence. And as I've said in other videos, I think the reasons part is the trickiest part. So if you ask a physics student, why is there no push towards the outside of the turn, hopefully they'll be able to tell you something, especially after a 3-week unit on it. I would hope that they'd be able to come up with a fairly decent answer. I don't know. I hope that helps. Anyway, that's all I've got. So if you have any questions, please let me know. Thanks for watching.